Hi, hello everyone. Today we're going to be working on our post-processing pipeline, and for that, basically, what is post-processing? Well, basically, post-processing is something where you rendered the entire screen, which we have now, and then we can apply some kind of post-processing to it. Basically, we can create maybe grayscale shader, or color shader, or like CRT effect, whatever. And how it works actually is well, the idea is to basically use this texture and just render everything off screen. So let's imagine this is not rendered here, rather it is rendered to some destination texture or whatever you want to call it. It's just going to be an empty texture. Basically, we're going to create texture as usual, but it's just going to be empty. And then we render scene to it, right? And then we use that texture to actually render. So then in the next phase, we're actually going to render some quad. Basically, that's going to cover entire screen area, right? If you imagine this V1 being here, V2 being here, you get the idea. And then you can use this texture to render to that quad. So let's say we have asteroids here. Let's imagine that it's not DT, rather it's some asteroids. So we get the texture and we render it. But since here this part now, we can apply any shader that we want, and then we can apply any effect over the texture. Well, you're going to see how it works. We're going to create really simple shaders, maybe just something to get warmer color for our game or grayscale something, and then that should give you an idea how it works. But basically it's just like rendering to some geometry which will have its own shader, and then we just create basically we manipulate those pixels from the shader, right, to do something, and usually it's just like pixel manipulation to get certain color, certain look. Well, anyway, I don't want to explain it further because you will get it once we code it. So for that we can just start with our shader, and let's just call it simply post process. Yeah, that's quite alright. VGSL shader, and then what are we going to have in the shader? Well, take this one, just copy it, and then let's see. So we're still going to need texture coordinates because we're going to be rendering that texture, which will hold our screen, but we don't need color here. So we can get rid of that. We don't need this projection matrix. So because we're just going to map our position directly. Position is vec2, texture coordinates are vec2, it's fine. Here, get rid of projection matrix, we don't need it. Get rid of this color, so we are putting just position texture codes. This is fine, however, since we don't have group 0 anymore, this becomes group 0. And then here we can just say our texture color dot red. So this is our post processing, right? We just here actually I'm going to do this screen texture so that you know what's happening, and then we can manipulate that screen texture, and let's just say we want some warmer color here, so we can multiply this by 0.8 0.8, and then we're just going to output that screen texture. All right, that's how it works generally shader wise. So now we need to set it up from the CPU code and everything. So let's get to that, and for that I'm just going to create some post process, and I'm going to call our post processing effects. So we're going to export that post process effect. All right, and for that we're going to need to set up a bunch of things one by one. So let me see how it will look like. Alrighty then. Alright, let's just, we have that. We're going to need a constructor, which is going to take device, private device, GPU device. We're going to need to create empty texture, and for that we're going to need to know width of the texture, and then we're going to need to know height of the texture as well. So let's create a texture. Public texture, GPU texture. All right, not GPU texture, right? We had this wrap object that holds the texture and the sampler. So we can immediately go to our public, and this is going to be async initialize. And then for the texture, we had our constructor texture dot create, and we're going to need to create empty. So we haven't created this one yet, we're going to do it now, but we're just going to create empty texture. And let's add that method. So I'll just going to copy this, go to our texture, and here public state static async, let's create empty texture. So we're going to need a device, GPU device with height and height number. And for that, it's going to be largely same as this one. So this we can copy even, but we don't have image, we just have width and height. We just don't have to copy this data, and we don't have to call this either. So we can just create sampler and then return that texture. So basically it's kind of same, we just don't have width and height. So here we had this idea of ID, but I'm just going to pass empty string here and width and height. Right? So you need texture and you need sampler. And the difference is we actually don't have any data for the texture now. Okay, alright, that should cover it. So we have our texture and we need to await it here. Alright. Then further, I think we don't need to initialize it. It's created. We're just going to place this here. So we are going to need this geometry that will cover our screen. So basically the idea of this geometry is to cover this, and then the edges here as well. So let's do that. And for that, we're going to need private. This can be private GPU buffer. We have a buffer, and we're going to say this GPU buffer. And if you remember, we had utility class for it. So buffer util. Not create vertex buffer, and I'm not going to use index buffer, so we can just create it like this. So what are we going to have? Position, xy, and then x coordinates, uv, and then we can say, let's go from the top left, then we can go top right, then we can go bottom left, actually, why not? And that's our first triangle. So first triangle, and then we can create a second one. So we can go from, I usually like bottom. Well, let's just go with suggestions. Top right and then bottom right as well. Alright, we have that. So those are our texture coordinates that we're going to use. And now we need to set up a pipeline and bind group layout. So what's easier? So let's just go with pipeline layout. So let's get started with our bind group layout. So we can say const texture bind group layout. So we're going to use this device, create bind group layouts, takes entries. So we have binding 0, it's visible in fragment shader, and actually not this, it's sampler. And we just create default. Here we don't need to provide anything to our sampler. Similar with texture. So what are we creating here, right? We're describing a layout that's going to be used for our post process. For this, right, you can see binding here 0, and it's of type sampler, and then binding 1 is of type texture, and the group is 0. So group, we set group when we pass it in a draw method. So right now it's not important. All right, we have that. And then what I'm going to need is to actually create this texture bind group. So we can find it here. And let's just say here this and this. And then let's just say this texture bind group, create bind group. We paste that layout. So we have our entries. So binding 0. What is the resource? It's our texture sampler, right? So we're checking our texture wrapper that we created. It has sampler, right? This texture has sampler and WebGPU texture. So binding 1 is going to be that texture. Texture create view. So it's view into the texture. All right, that covers our texture bind group. Further, we need to create a pipeline, basically, and this is probably the biggest method. And for the pipeline, we actually need to import that shader. Right? So let's import our shader. Let's just say shader source from shaders. Is it shaders? Yes, it is shaders, and it's called post process. Here, process, and then just place question mark row at the end to import it as text. And then here we're not going to need shader module. We paste the shader sources code, and then we can work on our GPU render. GPU render pipeline descriptor. So we need our layout. We paste our texture bind group layout to our layouts. So layout and bind group. Actually, didn't I already have bind group layout? Oh no, it's fine, my bad. I was thinking something else. All right, then we're going to need our vertex stage. So module is our shader module, entry point. Let me check. Fragment main, vertex main. So entry point is vertex main. Further, we have our buffers that we need to describe. So what are the buffers here? Well, okay. So for our buffers, we have 2 of them, and you can see that here. At location 0 we have position, which is of type vector2, and texture coordinates at position on location 1. So let's do this. So we're going to have array stride times float, 32 bytes per element, right? Stride is size of our single vertex, which in case here has position of x and y, that's 2, and then we have texture coordinates of u and v, and that's also 2 components. All right, and then our attributes. So first attributes for our position, it's at location 0. As you can see in shader, we don't have offset here, and then format is float32 times 2, right, because it's float, and then 2 float components x and y. Here we have location 0, we have to offset for this position, right, of 2, so that's why we're offsetting here, and then we take bytes per element, and here the format is also this for our UV coordinates, and that's it for vertex stage. And then we have final fragment stage, at least I think that's the last one. Right, shader module, entry point, we use fragment main targets, but with targeting format. Which format are we going to use? It can be that format. And then finally, what are we drawing? What is our primitive? So we're drawing triangles. I think that's it for our descriptor. It's a rather large method, but that should cover it. Okay. And then we finally need to create a GPU pipeline. So what are we going to draw? Private GPU pipeline, our render pipeline. Here at the end, we just need to assign it and pass that description that we had of the pipeline, right? Okay, that covers it. And I think we're almost done here. So we're getting there. So we need now public draw. And here we're actually going to create pass destination texture view. So GPU texture view. So what is this texture view going to be? Well, usually it's going to be canvas, right, view. But as I mentioned, we can also draw it. We don't have to draw it to canvas. We can draw it to another off-screen texture, right? So here either it's going to be canvas texture or some other texture which will be off-screen texture. All right. So whenever we change the texture, we need to create a new command encoder. So that's why I'm creating it. So we need to begin new render pass, call our attachments. So we're going to pass the texture. This load value, it's not actually important. So what's important is load up. So we want to clear the texture and then store it. And I think, oh, my bad. I think that should be it actually. Our new pass encoder, and then we're just going to use that pass encoder to set up everything. So we need to draw our pipeline, set up our vertex buffer, set up our bind group, finally draw everything, and then we can finish that render pass encoder and submit it to the queue. Alright, that's it. So basically the idea here is we set up where we want to draw, right? To our canvas or our off-screen texture, off-screen texture, off-screen texture. Then we usually set a pipeline, right? So our shaders, pipeline contains shaders and stuff. Our vertex buffer, so our data for drawing these edges, and then our texture bind group. So basically we're setting our texture, and then we just draw it. All right. Further, I'm just going to create it through a factory. So let's just call this post effects factory. And then we're going to export it. It's going to take for the constructed device. And then actually I'm going to need private width information and then private height information. And then I'm just going to create post-process effect, which is all right. We need to import it, initialize it, and then we just return it. Okay, and in our engine, we can now create that factory. Oh, my bad. We can initialize it somewhere down here in initialize method. Not this, rather it's this effects factory. Yeah, effects factory. And then what we're going to need to do. Well, we have our program. We do have what we want to draw, but we don't have a way of saying, right? If you look at the draw method, here it's where we're saying actually, okay, draw to canvas, right? Don't draw to off-screen texture, draw to canvas. So we're going to need somehow to know of this texture that we want to use for drawing, and we can just create it somewhere over here. It doesn't matter really. It's going to be private destination texture. And it's not of the type GPU texture, it can be texture. It's probably fine even if it's GPU texture. All right, we're going to have that, and also we're going to have the constructor is empty. We can delete it. We're going to have public set destination texture, and here actually my mistake. It needs to be also null. So if it's null, we're drawing to canvas. If this is null, we are rendering to the screen. That's all right. So here we're just going to set it. And then we will go back to our draw. So this, let's just cut it. Say here texture view. And we can use this as a texture view. But if we have our destination texture, so if our destination texture does not equal null, what are we going to do? Well, we're going to use destination texture, otherwise we're going to create this view. We're going to paste it here. And I think that should be pretty much it. So only thing now is to test it. And let's test it. So in our main, we're going to create that effect. Const post-process effect. Engine. Effects factor, create post-process effect. So here we need to swap our engine so that it draws to that off-screen texture. So what is it going to be? Use set destination texture, and it's on our post-process effect, this empty texture. So it's in placeholder, texture, and we obviously need to await it here, but since this is not async, change this to async. Let me just do something quickly. So change this to async. Here await for that post-process effect, and then we can use it. And it's stuck now because it's actually drawing to off-screen texture, not to canvas anymore. So we just need to say our effect. So it's going to be post-process effect, draw. And here, what are we pasting? We're actually going to paste, well, this texture, right, to which we have drawn already. So we can just say post-process effect. Or not, actually, no, my bad. So we're drawing to canvas here, actually. So my bad, we're going to need to create a new method. I wasn't thinking this through properly. So we're just going to create a small method, which is going to say public get canvas texture. And here we're going to say return this context get current texture. So it returns GPU texture. So that's in our engine. And now we're rendering to canvas texture. So it's going to say engine get canvas texture. And I'm not sure why is it suggesting this. We don't need it. And I think it takes actually texture view. So obviously there is a bug. Let me quickly check what it is. Aha, color format. All right. Let's take care of that as well. So here in our VGR sample count. Okay. All right. I think I have it. Should be relatively easy. We had this sprite pipe. Where is that effect? Here. Can I just swap the texture here to RGBA? No, maybe I should just flip this empty texture to this format. So let's do this. Oh, sorry, my bad. When we're creating empty texture, now post-process effect, we're just going to paste this. So I need to paste another parameter, which is here format is of type GPU texture format. So we can say here format, GPU texture format. Okay, and then here we can paste that format. And I need to save everything. All right, it works now. So only format was wrong. As you can see, now it has this red tint, and that's why is that? Well, because in our post-process effect, we increased our red value here, right? If I was to increase it to something like 2.0, it's really red. But you can also do something different. Like, for example, you can create a sort of grayscale effect just by using a bit of averaging. So we can say float average. And then for our average, you can do a screen texture red, green, blue, divide by 3 so that you get the average. And then here we can say, let's just change this to var. We can say vec4 average 1.0, and then you have this grayscale. Well, grayed out call, so average. Perfect. All right, just to quickly recap. So the whole idea of this is actually just to render our scene to off-screen texture, and then to use that off-screen texture as an input to another pipeline, which will actually draw to screen. And that's basically it. And you can see it probably if I was to maybe debug it. Let's try debugging this a bit, so just that we see what's happening. Where are you? Okay, let's reset it. You can see here textures, and this is our screen texture, right? So this is screen texture, and then it's used somewhere in our frames, right? We have our content, and we're actually out. This is canvas, but it's using that texture somewhere here. Let's inspect this frame a bit. Let me just see. We have commands, create view, write buffer, set pipeline, set index buffer, set vertex buffer. That's probably for it's a bit hard to see here. Well, anyway, you can probably play with it and try to inspect it, but the whole idea is just like to have some to render our scene to off-screen texture and then apply it here. And so just that you also get a bit of idea how this works a bit further, I'm just going to do this quickly. So let's say I'm going to place here 0.5, 0.5. So our first triangle is going to be scaled down, right? And you can see it's goes through here. So you don't have to use it for post-processing this, right? If you want to render your scene to a texture, right? And then you wanted to have like some sort of facet in a game that represents camera that it's looking somewhere and you're looking through it through TV or something, you can also do this, right? But that's the idea of it. Anyway, that's it for this video. Hopefully you enjoyed it. If you did, please like, subscribe. If you have any other questions, feel free to ask on YouTube in comment section or join the Discord channel as well. So you can ask questions there as well. That's it for this time. Next time we're just going to do a bit more advanced examples of post-processing. So all the best.